Hello again, all. Welcome back to the Knowledge Tower, where we investigate the science of the Bionicle legend. Today's investigation: Nova Blasts. A Nova Blast is the most powerful ability a Toa has, where they unleash their full reserve of elemental energy in one massive destructive burst, the effects of which vary upon the specific element of the Toa in question. In this video, we will examine the canon details of the Nova Blasts to find out just how much energy this contains. Oh, and spoiler alert, it's way, way larger than you think. To find out how much energy a Toa must contain in order to perform a Nova Blast, we must first set out some parameters for the blast itself. Thanks to answers from Greg Farshty, the writer of the Bionicle books, we know that the radius of a Nova Blast from an average Toa would extend beyond the borders of the city of Metru Nui if it was released there. Greg did not state exactly how far beyond, so let's be conservative and set the blast radius at the border of Metru Nui exactly. Metru Nui canonically has a length of 47.6 Kaio, which works out at being 65.212 kilometers when converting to human units. So, let's make the Nova create a circle around the Toa that has a diameter of 65.212 kilometers, thereby encompassing the whole city. Now that we have a size limit for our Nova, we need to set a few more parameters before we can get into the full calculations. Firstly, we need to find out what the exact effects of the Nova Blast are, as well as pick an element whose blast can be what we base the investigation on. The elements that do not have real-world equivalents, such as psionics, were immediately discounted from the list of possibilities, as were the elements such as light that are energy-based, as they would be the most difficult to work with due to the larger number of variables involved. Of the remaining elements, iron was chosen for two main reasons. One, of all the substances that the different Toa can create, metal is the most dense, and so would pack the most mass into the same volume of all the options available. This means that it is the best candidate to find out the upper limit of elemental energy capacity that we are looking for. And two, from quotes from Greg, we know exactly what the effect of an iron Nova Blast is, with Greg stating that a Nova of this element would cover everything for miles around in metal. This is important as it shows that a layer of the element is created inside the blast radius, rather than creating another shape such as a dome, as would be expected for something like an air nova. Now, technically speaking, a Toa of iron can create any kind of metallic protodermis. However, given the element is called iron, we will be substituting the properties of the real-world metal in place of the unknown properties of metallic protodermis for the purposes of this video. We will also be setting the thickness of this layer of iron that the blast creates at being 1 centimeter thick. This may seem small at first glance, however, as we will see later on, it really isn't. Okay, now that we have all of the parameters of the Nova, let's set the scene. Toa Zarya finds himself in the middle of a vast plain of the northern continent, readying himself to release all of his elemental energies in one massive explosion. Maybe there is an army of Rakshi bearing down on him. Or maybe someone just bet him he couldn't beat the Matoran universe record for the largest ever Kanoka disc. Whatever the reason, he lets his power build until it cannot be contained anymore, and boom. Within seconds, elemental energy streaming out of him is converted into mass in all directions and creates a vast disk of iron all around him. From before, we know that this gigantic disk has a radius of 32,606 meters and a thickness of 0.01 meters. But how much iron is that really? To find that out, we need to figure out its volume, and from that, its mass. Given that this huge mass of metal is the same shape as a very wide and very short cylinder, we can use the formula to find the volume of a cylinder to find the volume of the disk, as shown in this equation. Subbing in the numbers, we get a volume of 33,399,881.13 meters cubed. The density of iron is 7,800 kilograms per meter cubed, and multiplying that by the volume from before, we get a final mass measurement for this disk of iron of 260 billion kilograms. That is a very big disk. To give some context to that number, the disk Toa Zaria just created weighs 50 times as much as the Great Pyramid of Giza. Those rock shear history. But we aren't done yet. We still need to work out how much elemental energy it took to make that disk. The disk of iron was created in that instant by the nova blast after all, with all the elemental energy of Zaria being converted directly into the mass of the iron. Energy and mass are directly related, as described in what is most likely the most famous physics equation of all time, E equals mc squared. This equation shows the relationship between mass and energy, with the energy equivalent of any mass being the mass in kilograms multiplied by the speed of light squared. And with the speed of light being just under 300 million meters per second, our final energy figure is going to get very large, very fast. Once again, plugging our known figures into the equation, we get our final figure of the energy of a nova blast as being 2.34 times 10 to the 28 joules, also known as 23 octillion 400 septillion joules of energy. That's a 2 followed by 28 zeros. That is a number so large that when I looked up how to say it, there were words in there that I don't think I've ever actually said in my life before this point. For context, I tried to compare this to the largest nuclear bomb ever detonated, Tsar Bomba. However, the energy contained in that bomb wasn't even in the same league. In order to release a nova blast, a TOA must contain an elemental energy reserve that is 112 billion times larger than the energy of the largest bomb ever detonated by humans. To put it another way, our Sun puts out approximately 380 septillion joules of energy per second. The nova blast we just calculated was created from an elemental energy reserve equivalent to the energy output of the entire Sun for 60.66 seconds. The energy of the entire Sun for just over a whole minute. It is insane how much elemental energy a TOA must contain in order to create matter out of energy like they do. But if we assume that all TOA have the same amount of elemental energy at their disposal, that is when things start to get really dangerous. What would happen if a TOA of light or fire, whose element is based on energy rather than matter, were to go nova? Remember, the energy of a single nova blast is 112 billion times more powerful than the largest nuclear bomb ever made. If all of that energy were to go into one single blast of light or heat, you could say goodbye to life on whatever planet the TOA went nova on, along with a sizable chunk of the planet itself. Hopefully, the great beings had the sense to limit the elemental energy reserves of these energy-based elements to a more reasonable level. Because if they didn't, well, I can certainly see why they created Marandar. As if you annoy a TOA of light enough, they have the power to destroy worlds.